implementation of a zigzag list in C++. All right, so given a linked list, rearrange the node values such that they appear in an alternating low, high form. For example, if you're given 1, 2, 3, 4, 5, 6, 7, it should return 1, 3, 2, 5, 4, 7, 6. As you can see, that's low, high, low, high, low, high, low. Can you make it alternate with the high, low, high, low? So as I explained in the introduction, I'm going to use a strategy where I keep track using a flag. So if I start the flag with a true statement, then it's going to start with low, high, low. But if I start the flag with a false statement, it's going to start with a high, low, high, low. And then I'm going to compare the adjacent elements. And I'm going to use a strategy that if the flag is true, I expect the current to be greater than the previous. And because I'm always looking backwards, I'm going to start one spot ahead of the beginning index. And then if the flag is false, the opposite should be true, which is the current is less than the previous. If those two statements are not true, then I'm going to swap the two elements, the previous and the next, the current spots values. I'm going to swap them. All right, I'm going to implement this in C++ now. I've done the same using JavaScript, Python, and Java. Just in case you're not too fond of C++, you can check the implementation in those two. I'm going to implement this using an array, and then I'll go implement it using a linked list. So that because it's kind of a lot going on, so an array is easier to think through things. But you're going to see that the implementation is the same and doesn't matter. Anyway, let's get started. So there's no file there. So I'm going to create, I'll just make it a main. All right, so the first thing we're going to bring in the input-output stream. And I'm going to use a namespace of std so that I don't have to be putting the std in front of everything. I'll just use that namespace, and I'll write the main function, and I'll just return 0 here. All right. Like I said, I'm going to implement an array, zigzag, and let me put a spot for that. And then later, I'll use list here. But let's start with an array first. I'm going to instantiate an array of integers, and I'll just put 1 to 9. And as it's customary in C++, I'm going to get the length of the array by using the size of, which is done by getting the total size of the array and then dividing it by the size of int. But I can use the int. In this case, I'll just use the first element. It's the same thing. And let me also create like a print function, which just prints out the array function, because I know I'm going to do a print here, then zigzag, and then I'm going to print again. So this will be the print before zigzag, and then I'm going to have another print here after zigzag. And I'm commenting it out right now because I'll just go one step at a time. And here I'm going to zigzag the array. All right. So let me implement the print function here. It's a utility function. So it's going to be returning nothing. It's going to be called print. It's going to receive an array pointer, pointer to the array. And it's also going to have the length of the array. And create something like an array of numbers like that. So I'll start with an open parenthesis or open square bracket, which I'm just going to see out here. And then I also like see out the closing parenthesis, square brackets, I mean. And create a new line there. But in between there, I'm going to print the array. I'll just print out each element of the array. And also to put the commas and spaces there, I'll check if I is less than 1 less than the maximum index. And in those spots, I'm going to put a space and a comma there. And then if we compile this, we'll just say zigzag. Okay, so the array is being printed. So this is not really part of the problem, but it's easier just to see it by using it that way. Anyway, so let's go to the second part. So anyway, before I implement this zigzag, I'm going to print again here so that you see that that was a typo. Okay, so both of them are printing the same array. And now I'm going to implement this zigzag function. It's also not going to return anything. It's going to receive a pointer to that array, and also it's going to receive the length of the array. And we are going to use the same strategy that I talked about in the introductory video. We'll start with a true flag, and then if flag is true, expect the current element or the element here to be greater than the previous element. Else, if flag is false, expect the current element to be less than the previous element. Otherwise, swap. All right. So then we're gonna now go through for, first of all, we need the flag to be true in this case. And then we're gonna loop through. We're gonna start at 1 because we're always checking the previous element. And we have to be in bound for the array. And then we're gonna start checking. If the flag is true and the current element, here it says greater than, so we have to do the opposite to check if it's no the opposite of that. If that's the case, we're going to swap. We're going to pass in the element or the array, and then we're going to pass in the left part of the array, and then the current array. This is for the true case. We're going to check for the false case. So if the flag is false, and here we expect it to be less than. So for this to swap, it has to be the opposite of that. All right, and then every time after we do the checks, we're going to flip the flag. Kind of like a switch. All right, and as you can tell, so we need to implement the swap method. It's going to return anything. It's going to swap. It's going to accept a pointer to the array. And it's going to have the left index of the array that you're swapping and the right index of the array that you're swapping. And we're going to store the index or the element of the left array. We're going to store it in a temp variable. And then now we're going to rewrite or replace that left element with the element on the right. And then we're now going to put what was on the left onto the right. And at this point, we've successfully swapped elements. All right, so zigzag, 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 okay. All right, so if everything is correct, this should compile and work. All right, so it totally works. So this is the original one, and then this is a zigzag array. Now, if we wanted to start with a high number, if we change that to false, yeah, that's high, low, high, low, high, low, high, low. Okay, so I'll just put that back to true. All right, so we've implemented this with an array. What about a list? We did talk about that, right? So I'm gonna use a template library called a list, and I'll just call it linked list here, which I can initialize with elements like that. But obviously, this list doesn't exist, so we have to bring it in. My C++ is not up to date. You can do this in the new, like the new method in the new C++. I need to update that. But wait, did that work? Let me just make sure that it does work. Yeah, right. Yeah, my C++ is not up to date. It needs to. I know I can instantiate it if I did do something like an array of that, and then I did something like begin and then end. I think that would work. So the end is 9 there. All right. Okay. So anyway, my old C++, I need to update this. It doesn't allow me to instantiate that, but I can use an array, a C language array, and use it for that. And I'll just use the begin and end for that. And once I instantiate it, I'm going to also print the list. Obviously, I'll print it twice. Before zigzag, and then print it again. After zigzag, and then I'm going to zigzag here. Let's name the list. But we don't have the print method for the zigzag or for the list. So I'm just gonna create a helper utility function here underneath here. I also call it print, but because we're passing in a list, it's gonna overload that and we'll print the correct stuff. It's just gonna use the correct method. All right. For the list, I'm going to use an iterator. So I'm going to instantiate an iterator, which I'm going to call it. And I'm going to use kind of like a visually attractive thing to see, to where you start with a head, and then you end with the now pointer. And then in between I'm gonna iterate through and the list by instantiating the iterator to start at the beginning. And as long as the iterator hasn't reached the end of the list, and we're going to traverse that, and we're going to be printing the element elements in the iterate, and I'll just append an arrow there so that it looks good. All right, let's print this. We'll compile and then we'll print. All right, so 1, 2, 3, 4, up to there, up to there. So then the print method here, I'm gonna put an end line at the end there so that whenever it prints, it can go to a new line. Okay. So you have the first one and the second one, and it's printing twice because I've got these two print, the before and after, but I haven't applied the zigzag method. So the two are going to be equal. So I'm going to uncomment the zigzag method for that. And this zigzag is going to be interesting. So we're going to use something similar to that. So I'll copy that. And I'll close that. But this one is going to just receive a list of ints. And it's going to be tied with the original one. And I'm doing this because what I want to do is to kind of like create a whole new list and then replace the list I'm going to create with the original list. And here we're not using arrays, so I'm going to use current with previous, and also current with previous. Otherwise, we're going to swap, but the swap here will be interesting. So same thing as the array, we're going to instantiate a flag to true. And as I stated, I'm going to create a whole new list here to play around because I need to be traversing back and forth. And then once all that is fixed, I'm going to replace the original list with the list I'm going to create here. So I'm going to create a whole new list of ints. I'm going to call it the list 2. And then I'll also instantiate an iterator that I'm going to use to be traversing the first list. I'll call it right, and then like in the print function, we we started it at the beginning in the for loop, but in this one we're going to use the while loop. So as I created here, I'm going to also point it to the beginning of the list, and then I'm going to like keep track of the previous value, and in order to get the value out of the iterator, I'm going to reference it, get the value right there, and I equate it to the previous one. Now I'll traverse the list, comparing items and adding them to list 2. All right, so as long as the iterator hasn't reached the end, I'll start comparing them. Here we have this previous item we're keeping track of, but every time you kind of go to the next one, I'll instantiate the current value we are on. And what I'm going to do is, since we had the previous one, I'm going to dereference the value. But before I do dereference the value here, I'm going to I'm going to move the iterator one spot forward and then dereference that value. All right. And now we're just going to do the same checks. So if the flag is true and current is now here I would literally like just check for the truth. So if it is true, if this is true, I will just be pushing the items to the new list. In the array we were doing the opposite, but here we're just going to literally do the exact, as long as this statement is true, I'm going to push that item there. So as long as that is true, and we're starting with a true statement, so the previous one is less than, or the current one is greater than, so everything is okay. So I'll push that into the list 2, and then I'm going to make the previous one to equal the current one, so for the next round. And I'll repeat the same truthfulness, but this time it's for the false. And again here, we're literally going to check if this is all true. Then we're also going to again push that, and then the previous is going to be, we're going to make the current one to equal the previous one. Otherwise, this time, this is where we're going to push the actually current one now. But if we do push the current one onto the list, that means the previous one is still the previous one, so we don't need to reassign the previous one, so that everything is okay. And when we reach the end of the checks, we're going to flip the flag. And once right, so once we are done with the while loop, that means we've traversed the whole list of 1. We're going to replace list 1 with the new list that we have. And to replace, I'm going to use the method called assign, which is going to grab the beginning of list 2 to the end of list 2. So just to go through it. So the zigzag for the list. So we have a reference to the list itself. We instantiate a flag of true. And then we make another list here, which we're going to be putting items from list 1 into, because we're going to be doing multiple comparing and it's easier just to use 2 lists. Then we get an iterator on list 1. We start at the beginning. We have a reference to the previous item at the beginning. Then we check, as long as the iterator is not at the end of the list 1, we make the current. So we kind of like move the iterator 1 step forward. Then we dereference the value. Then we compare that value with the previous one. So if this statement is true, then we just push the previous one onto list 2. and then we make the current value the previous one to use for the next round. Same thing here, but if that's not true, if either of these are not true, that means the previous one needs to proceed to the next round. So we don't need to reassign the previous one. We're just going to push the current one onto the list 2. And then we flip the flag, and then we replace the values of list 1 with the newly zigzagged list 2. All right, so if everything worked out properly here, if we compile, and the zigzag works. 1, 3, 2, 5, 4, low, high, low. And the same thing goes if we want to start with high instead of low. We just change the flag to false there. We compile. And high, low, totally works. If you have any questions, you can ask me. Oh, this was actually fun. If you want to see the code in Java or JavaScript or Python, there will be a link somewhere here. It's also done in there. And tell me what you think. Thanks.